Okay, so welcome back. Let's consider this sequence here. Okay, and so this is another one that at first it's going to be a little complicated. This is probably one of the more complicated ones. And now once you get used to these, you'll start to see that what's going to happen. So I know that an exponential e, the natural exponential, is going to come up in this one. Okay, so now when it comes to these again, let's use functions, because we know that this piece is going to go to 0, okay, as n gets large. But this is going to infinity, so this whole thing is getting larger, okay, because you've got something that's bigger than 1. Okay, so when you take a power of something bigger than 1, it grows. So let's see what happens. So in this, again, just like in the last one, we're going to look at a function. So let's look at the function f of x equal to 1 plus 4 over x to the x power. And let's take the limit of this thing. So if we look at the limit as x approaches infinity of 1 plus 4 over x to the x power, what does this give us? It gives us, well, this is going to go to 1, and this is going to infinity. So 1 to the infinity is an indeterminate form. Okay, well, we've got to do something with this. Well, what do we do with this? Well, we're going to have to set this equal to, a function. Okay, so let's do this. So let's let this equal to y. And so what I'm going to do is I'm going to take the natural log of both sides, okay? Because I want to get the exponent out. So let's take the natural log of both sides. So I'm going to take the natural log of y, and now what I'm going to do is I'm going to solve for the natural log of y, which is going to be the natural log of the limit as x approaches infinity of 1 plus 4 over x to the x power. Now, since the function f of x is continuous over its domain for all, x greater than or equal to 0. What that means is I can go ahead and exchange the natural log and the limit. So I can make this equal to the limit as x approaches infinity of the natural log of 1 plus 4 over x to the x power. And now I can use my property of logs and pull the x out. Okay? So again, I'm trying to rearrange this. Because I have the indeterminate form 1 to the infinity. Or 1 to the infinite power. Okay, now. So now I can go ahead and pull the x out. And let me write this as equal to the limit as x approaches infinity of x times the natural log of 1 plus 4 over x. Okay, now what's going on? Well, if I take the limit of this, well, now this equals what? This is going to go to infinity times 0. Which is another indeterminate form. So now what I'm going to do is I'm going to, again, I want to, in this part, I'm trying to get the L'Hopital's rule. So now what I'm going to do is I'm going to rearrange this as a ratio so I have 0 over 0, because then I can use L'Hopital's rule. So I'm going to write this as the limit as x approaches infinity, and I'm just going to take the x and I'm going to divide by the reciprocal. So now what I'm going to do is I'm going to have the natural log of 1 plus 4 over x over 1 over x. And so now gives me 0 over 0, which is one of the indeterminate forms, and I can use L'Hopital's rule now. So now, by L'Hopital's rule, this is going to equal the limit as x approaches infinity of what? The derivative of the top times the derivative of the bottom. Or excuse me, divided by the derivative of the bottom. So what's the derivative of the top? Well, the derivative of the top is going to be of the form du over u. Okay, so again, I'm going to take the derivative of the natural log, and let's see here. How do I want to do this? Okay, so if I make this u, right, so this will be so this will be, if this is u, if I make this whole thing u, well, let's use a different color. Right, so if I make, so you guys can see it better. So if I make that u, so the natural log of u, the derivative of that is du over u, right? So we take the derivative of the inside, and so the derivative of the inside is what? Well, this goes to 0, and this becomes what? Negative 4 over x squared, right? So this is going to be negative 4 over x squared divided by 1 plus 4 over x. That's the top. Now the bottom, the derivative of that is going to be negative 1 over x squared. So now, if we simplify this, we get the limit as x approaches infinity. Well, we're going to multiply by the reciprocal, so we're going to get negative 4. Well, the negatives are going to cancel, so this will be positive. So now it's going to be positive. Okay, because the negative on top is going to cancel with the negative on the bottom. Right, so if I pull this out here and just make this whole thing negative, this is negative. Negative divided by negative is positive. So this is going to be positive. So we're going to get 4 divided by x squared over 1 plus 4 over x, oops, times x squared over 1. Well, what happens to this thing right here? Well, this is just going to, if we multiply across the top and the bottom, what we're going to get is 4 over x squared, right? I'm just doing the numerators, times x squared. So I'm just multiplying these, and then I'm multiplying the bottom, which is 1 times this, which is still this. So it's going to be 1 plus 4 over x, right? Well, on the top, the x squareds are going to cancel out. And so I'm going to get the limit as x approaches infinity of what? It's going to be 4 over 1 plus 4 over x. And the limit of this thing, again, we can use the limit laws, but still, this is going to become, this 4 over x is going to go to 0. So this is going to go to 4. And so the limit, now be careful. The limit of what is equal to 4? Well, the limit of this is equal to 4, so the natural log of y is equal to 4. So be careful. That's not your final answer. Okay? All I showed was the natural log of y is equal to 4. Okay? So now we have to go backwards, and I have to exponentiate both sides, which means I have to raise both sides to the power of e. Okay? So what does that mean? Well, it means that y is equal to e to the 4th. And y is the limit of this thing, which is what we wanted. The limit of this, right? So we just found the limit of f of x. So the limit of f of x is e to the 4th. So this sequence also converges to e to the 4th. And that's it. Have a great day.